Today we're looking at section 10.1, which is solid geometry. So three-dimensional figures are going to be made up of flat or curved surfaces. Copy down what you see on the screen, including the picture of the rectangular prism, which has a face, an edge, and a vertex. This screen you do not need to copy down, you just need to know the difference between a prism, a cylinder, a pyramid, and a cone. So a prism is going to have two bases that are parallel, and they're called faces or bases, and they're connected by faces that are parallelograms, but usually rectangles. The cylinder's going to have bases that are circular. A pyramid goes from the base up to the opposite side, which is going to be a vertex. The cone is just like a pyramid, but it's going to have a circle for a base. This screen, you don't need to copy anything down. You just need to know that for all the prisms, they're going to be specific based on what their bases is. So the first one is a triangular prism because its two bases are triangles. Then a rectangular prism, then a pentagonal prism, which has two pentagons and all the sides are rectangles. Same thing is going to be true with the pyramids. It's distinguished by the base, which is either a triangle, a rectangle, a pentagon, or a hexagon. So here's the first example for you to practice on. Example 1A, you're going to classify the figure, name the vertices, name the edges, and name the bases. So this figure is a rectangular prism, or it could possibly be a cube. Either of those answers are probably sufficient, or both. The vertices, there are 8 of them. And to name them, you just say the points. So A is a vertice, B is a vertice, C is a vertice, D is a vertice, E is a vertice, F is a vertice, G is a vertice, and H is a vertice. So put commas in between all of those. The edges are where two faces come together. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 of those. There are 4 around the bottom, 4 around the top, and 4 around the middle. So if you're going to name them, one of them would be AB, one of them would be BC, one of them would be CD, and one of them would be DA. And then you just keep going around and naming all 12 of them. Example 1B, this time, has a base of a pentagon, but it comes up to this opposite vertice, so it's a pentagonal pyramid. The vertices are mostly all around the base, so point A, point B, point C, D, and E, but there's also F, so it's going to have 6 of them. And there are 10 edges. So one of the edges is AB, BC, CD, DE, and EA, but there are also edges going up to the top vertices, so AF, BF, CF, DF, and EF. And then there's just one base on a pentagonal pyramid, just this base down at the bottom, and we're going to name it A, B, C, D, E. Go in the most logical order. The next screen talks about a net. So a net is going to be a diagram of surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. So what you're going to do is you're going to look at the net. You're going to try and figure out which of the three-dimensional figures it's going to be. See what shape they are. If there's circles, or if there's rectangles involved, or if there's triangles, that's going to help you narrow it down. So here's an example. This is example 2A. You're going to describe the three-dimensional figure that can be made from the given net. So you're going to draw this net in your notes, And then hopefully you figured out that this one is a cube or possibly just a rectangular prism. And example 2B. So copy down the directions and the drawing. This one has a circle in it. And then if you were to fold this piece in half and connect this edge with this edge, it's going to make a cone. The last topic we're going to talk about is a cross-section. A cross-section is the intersection of a three-dimensional figure and a plane. So basically you're going to take a plane and cross it through any of the three-dimensional figures, and you're going to have a certain intersection. For instance, example 3A, you have this cone and this plane. It's intersecting right at the tippy top right here, so their intersection is just a point. But if it was intersecting it right here, it would actually be a circle. So it just depends where the plane is intersecting the three-dimensional figure and at what angle. If you slant it, it's going to stretch it one way or the other. So those are some things to pay attention to. The last example, example 3B, is a pentagonal pyramid, and the plane is just slicing it right through the middle. So the intersection, or what we call the cross section, is just this two-dimensional pentagon. Thanks for watching.